Remember, aluminum, not a metalloid. Okay, now let's talk about some general differences between metals, metalloids, and nonmetals. So first of all, metals, they're left of the staircase. They represent most of the periodic table. Remember, M in metals stands for most, 75% of the periodic table, in fact. They have the ability to conduct heat and electricity. They are shiny. Fancy word for that is lustrous. And then they have two kind of special properties. So the first property is they are malleable, meaning we can pound them flat into a sheet. So think of like sheet metal or thin sheets of like gold, things like that. A lot of substances, if you tried to pound them flat, they would crumble or break into powder or shatter. Metals don't do that. You can pound them flat into a sheet and they'll actually stay together. They're also ductile. That means that we can squeeze them and roll them or force them into a thin wire. Again, they'll hold together, they won't break up or turn into a powder. Final thing about metals is that they have high melting points, meaning that at room temp, so in the classroom, if you were to encounter a metal, pretty much every single metal you'd encounter would be a solid with the exception of mercury. Mercury is a liquid at room temp. So those are the metals. Then we have the staircase. The staircase represents the metalloids. And we said that the staircase itself, above and below each step, with the exception of aluminum, okay, polonium we're going to take off this list because we're going to consider polonium a metalloid, okay, so the only exception is aluminum. Anything above and below that staircase is a metalloid. They are solids at room temp, and their properties depend on the conditions, so things like pressure, temperature. As we alter the conditions, that will alter their properties. And the reason why these properties are kind of important is that they're kind of a mixture between the properties of a metal and the properties of a non-metal, which makes sense because they're on the staircase, which is the dividing line between metals and non-metals, so they share a little bit of each. Okay, one of the kind of advantages of their properties is that they can be used for a lot of kind of weird or strange applications, and one of the major applications that we have for metalloids is they're used in semiconductors. Semiconductors are a huge electrical component, meaning electrical devices use semiconductors, and so our technology today depends a lot on metalloids. Now, the last and final major group of the periodic table would be the nonmetals. They are to the right of the staircase. They vary in appearance, so they have different colors, physical properties. They are brittle, which means if I tried to pound them flat, they'd kind of shatter or turn into powder, meaning they are not malleable and they are not ductile. They are not shiny, okay? A lot of them are kind of flat or colored. And they have low melting points, which means that at room temperature, most of them are gases. Not all. You do have some liquids and some solids, but a lot of them are gases at room temperature.